In this video, we're going to talk about even and odd functions. We're also going to prove that the integral of an odd function over a symmetric interval is 0. We start with some definitions. F of x is said to be even if f of minus x is equal to f of x. That means basically the function is symmetric with respect to the y-axis. So you can imagine if you put a mirror across the y-axis, the left half of the curve is exactly the same as the right half of the curve. Alright, let's show that more analytically. Here we have f of minus x is equal to minus x all squared. That's equal to x squared. F of x is x squared. And we can see that we get the same answer. That means f of minus x is equal to f of x. So we have just shown that the function f of x equals x squared is an even function because it satisfies this condition, f of minus x is equal to f of x. Alright, now let's talk about odd functions. F of x is said to be odd if f of minus x is equal to minus f of x. And basically this means symmetric with respect to the origin. That means the distance from here to here, this distance, is the same as this distance. Alright, you can see how we have 2 and 8, and here we have minus 2 and minus 8. Notice that the y values are the same in magnitude but opposite in sign. So now let's show some steps here. So we have f of x is equal to x cubed. F of minus x is equal to minus x all cubed. That's equal to minus x cubed. So what we have shown is that f of minus x is equal to minus f of x. And this is the condition for an odd function. Alright, so now let's talk about integrals of even and odd functions. Assume that f of x is continuous on a closed interval minus a to a. If the function f of x is even, then the integral from minus a to a f of x dx is 2 times integral from 0 to a f of x dx. From the diagram on the left, you can see clearly that the areas just double up. So the integral from minus a to 0 plus the integral from 0 to a is going to be 2a. And for an odd function, if f of x is odd, the integral from minus a to a f of x dx is equal to 0 because the areas cancel out. So you can see how this area is going to cancel out with this area. Alright, we're going to prove that if a function is odd, the integral over a symmetric interval from minus a to a f of x dx is equal to 0. We start by splitting the integral into 2. So we write integral from minus a to a f of x dx is equal to integral from minus a to 0 f of x dx plus integral from 0 to a f of x dx. We will apply the substitution method to the first integral. So here we have integral from minus a to 0 f of x dx. We will let u be equal to minus x. Differential du is equal to minus dx. So x is equal to minus u, and dx is equal to minus du. We also need to change the limits. So x equals minus a, the lower x limit, we plug it into u is equal to minus x, and we're going to get u is equal to a. X equals 0, the upper x limit, plug it into u is equal to minus x, and we get u is equal to 0. So we have integral from the lower u limit, which is going to be a, the upper u limit is 0, f of x, so x gets replaced by minus u, dx gets replaced by minus du. Now the minus can come out, minus 1 is a constant, passes through the integral, minus a to 0, f of minus u, du. But we have to remember that the function here, f of x, is an odd function. That means we can rewrite this integrand as minus f of u du, because f of x is odd. So now the minus comes out and multiplies minus times minus is plus, so we get integral f of u du from a to 0. Now we have a property of integrals which tells us that if we interchange the order of the limits, we put a minus in the front. So minus integral from 0 to a f of u du. Alright, so what we have shown is that the integral from minus a to a f of x dx is equal to minus integral from 0 to a f of u du plus integral from 0 to a f of x dx. But u is the same as x. It's just a dummy variable. So we can rewrite this integral as minus integral from 0 to a f of x dx plus integral from 0 to a f of x dx. And clearly the answer is 0. So what we have shown is that if f of x is an odd function, if f of x is odd, then the integral over a symmetric interval, minus a to a, f of x dx, this integral is equal to 0. It can also be proven using the substitution method that if f of x is even, then the integral from minus a to a f of x dx is 2 times integral from 0 to a f of x dx. You can do that at home. It's actually pretty easy. All right, so now, if the function f of x is odd, areas cancel out due to symmetry. So the integral from minus a to a f of x dx is equal to 0. So let's show that. We have integral from minus a to 0 f of x dx, splitting up the integral into 2 pieces, plus integral from 0 to a f of x dx. And this part here is just going to be minus a, whereas this part will be plus a, and a minus a is equal to 0. And so for an odd function, the integral over a symmetric interval is 0, and that simplifies our computations. If f of x is an even function, the area doubles due to symmetry. So we can split up the integral from minus a to 0, f of x dx, plus integral from 0 to a, f of x dx. And that's going to give us a, this is the value for this definite integral, plus a, and it doubles up due to the fact that the function is even, and due to the symmetry of the function. All right, in the upcoming videos, we're going to look at some examples of even and odd functions, and we'll go over that in the next video. All right, thanks. I need to make some corrections to this video. On page 4, this integral, the differential should be du. So let's change that, du. And also on page 6, we should say that if f of x is even, then the integral from minus a to a f of x dx is equal to 2 times the integral from 0 to a f of x dx. All right, thanks.